Welcome to Physics with Mr. Brazil. Today we're looking at pulley problems. We're going to have an incline plane only on one side. We're looking at frictionless first, and then we'll look at a friction problem. So let's take a look at what's happening here. We're going to take the chord and make it the x-axis. Okay. Now, first of all, let's look at mass 7. Mass 7, if we put our actual vectors, we have a normal force, we have a tension force in the x direction, and we have Fg, and I'm going to call it Fg7. Now, Fg7 has some components that we can use. We do have a y component, okay, because I'm using the ramp also as part of the x direction. A lot of teachers like to call Fg perpendicular, okay, or I, for one, like to call it Fg7y because it's the mass 7. We do have a component in the x direction. A lot of teachers like to call this one Fg parallel, but that looks like an 11. I like to use numbers with my forces, so I call this Fg7x because it's in the x direction, it's aligned with the ramp, it's parallel with the ramp and the chord. Okay, so if we were to stretch out the chord, and this has no friction, so we're not going to have friction, we are going to have Fgx7 pulling to the left, so it's going to be a minus. We have a tension, but it's pulling to the right, so that's going to be positive. And let's use our pulley for a little bit of a reference here. And we're going to have a tension that's negative, so that's pulling upward on the 12 kilogram mass. So we're going to have an Fg12 that's positive. So now we can set up our component vectors. Knowing that this whole system is going to go to the right, so a mass total times A. Now I'm assuming it's going to the right. I made it heavy enough and I know that the problem is going to go to the right. But even if it came out A is negative, that means it's just going to the left and you just adjust. Okay? And that's for any future problem. Now, let's sum the net force in the x direction is going to be minus Fg7x plus T minus T. So this is just to get your frame of reference in mind. And Fg12 equals M total A. So A is going to equal minus Fg7x plus Fg12 all over M total. All right. And now we got to look at this Fg7. Fg7, if you looking to the left here, theta is between Fg and Fg perpendicular, or Fg7y. So that means Fg7x is equal to M7g sine theta, because it's a cross. Yeah, don't get confused. See, there's the I, that's the opposite. So it's going to be sine theta. All right, so let's set up our equation. So we're going to have a minus M7g sine theta plus M12g all over M7 plus M12. Okay, I'm going to put some values in. I'm going to factor out the 9.8. That's G times minus 7.0 kilograms sine 30 degrees plus 12 kilograms all over 7 kilograms plus 12 kilograms, and that's going to give us 4.4 4.4 meters per second squared. Okay, so that's our answer. All right, now let's find the tension. Now the way I like to teach this is I tell my students to cut the pulley in half, and we're just going to look, since the whole system is accelerating 4.4 meters per second squared, I'm just going to choose what I feel is easier, the y direction, and I'll explain what I mean by y direction. See, at first I made the chord x, okay? If you can look here at the sketch, okay? This was the x direction, the chord. Well, now I'm switching up by cutting the pulley, okay? Now I'll go to the right of the screen. I have the tension on the 12 kilogram mass going upward, and we have the weight, Fg12, the 12 kilogram, going downward, okay? So in other words, my coordinate plane now is the traditional x going horizontal and y going upward, and this whole system is now going downward a minus M12A. Okay, so our net force is minus M12A. Well, let's set up our math. I'll do it in blue. So here we go. Fy is going to be the tension upward minus Fg12 equals negative M12A. So T is going to be M12G minus M12A. So I'll put some values. I'm going to factor out 9.8. 0 meters per second squared, that's G. I got the 12. Sorry, reverse. Somebody's not thinking. G is not factoring out. I did that before. Okay, I'm going to factor out 12 kilograms, excuse me, and the 9.8 stays in the quantity second squared minus 4.4 meters per second squared, okay? Sorry about that thought glitch, but once you punch this in the calculator, you're going to see that it's 65 newtons, okay? And that is how you find the tension for an incline. Now, let's tackle friction, okay? That's our next task. So let me flip the page, make this black again, or let's go with blue. We're going to start with the same thing. I'm going to have my coordinate plane, x direction, going along the chord. For this, I'm not changing the situation. The only thing though, now we have friction going back, and we still have friction go, excuse me, let's put this back. We have Fg, or Fg7x, and we do have still Fg7y, and theta is still right here. So in other words, we're going to have to account for that. All right. So let's write these up for you so that way you have them. So Fg7y is going to be M7G cosine theta, while Fg7x is going to be M7G sine theta. We're going to need all of these, okay? And reason, because friction, okay, the force of friction, which I need you to memorize, everybody should memorize this if you're taking physics, is going to be mu Fn. Well, if we do the y, net force in the y direction for mass 7, you're going to see that Fn, excuse me, not equals, minus Fg7y, and this is all equal to 0 because the mass is not moving in the vertical direction of the slope. So Fn equals m7g, okay, cosine theta. That's part of the friction, okay? Don't forget it. Now, again, setting up, so going towards the middle of the screen here, we're going to have friction going to the left, so therefore it's a minus. And we also are going to have a minus Fg7x, okay, because it's pulling to the left. We're going to have our tension, a positive tension. Let's put our pulley here again for reference. And we have a negative tension that's pulling up on the mass, F12, and then we have the weight, Fg12. And this whole system, again, going to the right, a total mass times acceleration. Okay, just looks the same as last time, except we got a lot more to account for, so let's tackle it. Okay, so our net force in the x direction, that means along the chord, is going to be minus the friction, minus Fg7x. Okay, I'm going to just put the t's, don't really need them, but just for reference, plus Fg12 equals total mass times the acceleration. So A equals, let's set up our equation, minus F friction minus Fg7x plus Fg12 and our total mass. Okay, let's put our complete equation together. So this is going to be minus mu, and mu is 0.12, okay? That's going to be times Fn. So Fn is m7g cosine theta minus Fg7. So this is going to be in the x direction. So this is going to be minus 12g sine theta, okay, plus m12g. It's a lot. And m7 plus m12, okay? Those two masses. Whew. That was a lot. So let's go on to our next task. I'm going to factor out the 9.8 this time. So it's going to be 9.80 meters per second squared minus 0.12 times 7.0 kilograms cosine let's get that done right, 30 degrees, okay, minus, oh, I see an error. Let's see if I can fix that a little bit. Let's cut that out. Sorry about that. That's supposed to be M7. That was but that's the thing, write everything out so you can catch it, so you don't make mistakes, okay? So this is going to be 7.0 kilograms, all right, times sine 30 degrees. I'm happy I caught that, plus 12 kilograms, all divided by 7.0 kilograms, plus 12 kilograms. Yes, I could have wrote 19. I'm just writing everything out so that for your convenience, I hope. And this whole thing is going to be a 4.0 meters per second squared. Hey, that's cool. That makes sense. Now we're taking into account friction. It's going to slow down thing, so therefore our acceleration should be reduced. So we're going the right direction. Now, let's take that pulley, cut it in half. So our net force in the y direction, so I'm going to do this on the right side of the screen, is going to be equal to, and I'm just going to take the hanging mass, so we're going to have the tension minus Fg12 equals M12A, no different than the last, the frictionless situation that I explained, same deal, so same math. So T, the tension, is going to be equal to M12G minus, oh, this is a minus up above because it's a downward force, okay? So I forgot the minus. So if you need to, always write your free body diagram, which I should have done. So there's T, Fg12, and this whole system is going downward, a minus 12A. Okay, so I should have written that so to avoid getting confused math-wise, but it's okay. Caught it twice, huh? I'm going to factor out the 12 kilograms, 9.80 meters per second squared, minus the 4.0 meters per second squared. And this all equals 69.6 newtons, but we're 2 sig figs, so let's write that proper. So that's going to be 7.0 times 10 to the 1 newtons. And that also makes sense. That means our force is going to be a little more than the last problem. That had no friction. This has friction, so it's going to take a little more force to account for this acceleration. All right, this is how you handle hanging masses. Keep practicing. Enjoy physics. Till next time, bye.